f of g of x. Have you encountered something like that?
Yes, sir.
Yeah. Now, this is something that is very, very easy. Very, very easy. Now, when they give you find f of g of x, something like this, or it can also be written as f of g of x. So when you see something like this, it is the same as this one. It is the same as good. So this is what we are going to do. You realize that now the g of x can be found inside the f. So what it means is that pick the value or the expression that represents g of x and then fix it inside where you find x in the f of x. Very, very easy. So now this is going to be 3, then I open a bracket because x is here. So I am going to fix in the whole expression for g of x inside. So I have 6x plus 4 plus 6. Now the next thing I do is to expand. So now when we expand this, 6 3 is 18, and then x plus 3 times 4 is 12 plus 6. Now you realize that 12 and 6, they are like terms. They are all numbers. So I can add them. Before I continue, let me clear out this and see. If I have a number and a number, so I have addition. Today is our first meeting, so I want to go very basic for you to understand the fundamentals of functions, and then when you are doing any work, it wouldn't be very difficult for you. So addition, subtraction, division, and multiplication. Good. Now I am going to pick numbers and variables. In mathematics, when you represent a value by an alphabet, we say that that value is a variable. So if I have addition, so 2 plus 2, now I have 4. It means that when I add a number and a number, I have a number. It can give me a result. Now the next one is a number and a variable. So give me any variable. We represent numbers by x, right?
Yeah. A.
And then a. Yes, by m and then b. So I would say 2 plus a. Now, this 2 plus a will continue to be 2 plus a forever, because there's no way a number and a variable can be added to give you a result. So this is either 2 plus a or a plus 2. You cannot add them. Now let me pick a variable and a variable. So a plus a. What are you going to have?
2a.
2a. So a variable can be added to the same variable. And then you have 2a. That is for addition. Now, if I have subtraction, so 2 minus 1, now I have 1. It gives me a number. If I have 2 minus a, this will also continue to be 2 minus a forever. So 2 minus a, you can't add it unless you decide to bring the negative first. So this can also be negative a plus 2. Negative a plus 2. Now a variable and a variable. So I have a minus a. Now what is a minus a?
0.
0. So now you see someone would ask, why is it that we do mathematics and then we like to involve alphabets? Now this proves that you can subtract an alphabet, which is a variable, from an alphabet, and then you have a number. You have a number. So let's move on to multiplication. So I have 2 times 2. Now 2 is 4, right? Now the
Yes,
next
sir.
one with a number and an alphabet or a variable. So I have 2 times a. Now what do you think 2 times a is going to give me?
2a.
2a. 2a. So you realize that now in both addition and subtraction, there was no way we could have added a variable and a number to get a common result. But in multiplication, it works. In multiplication, it works. Now let's see a variable times a variable. So what do I have for a times a?
A squared.
A squared. A squared. So you realize that now multiplication have special properties. Now you can multiply a variable in itself, and then you have a squared. Now division. 2 divided by 2. Now I have a number, right?
Yeah.
Good. Now let's pick a number and a variable. So I have 2 divided by a. Now what do I have?
Let's be 2 over a.
2 over a. 2 over a. And this will continue to be 2 over a forever, because there's no way you can divide a number with a variable. Now, this can also be written as you are an elective math student, so there are some things I will have to go a bit deeper for you. Now, this can also be written as 2a inverse. 2a inverse, like this.
Yes, sir.
It's called reciprocal. Have you heard reciprocal before?
Yes.
Good. So if I have a number 1 and I am dividing by a variable, good. Now this means that this a can come up, but it has to be an inverse. So this is the same as a raised to the power -1. This conversion is very, very important. When you do indices and logarithm, it is very, very important. You will need it. So this is it. Now, the reason why I kept these 2 here is that now this expression actually means 2 times 1 over a. Now, anytime a natural number, now natural number starts from 1, whole number starts from 0. Integers are positive and negative whole numbers. So anytime a natural number, or let's say a whole number, multiplies a fraction, it always multiplies the numerator. The one up is numerator. Now this one is called denominator. Very, very easy. It always multiplies the number up. So if 2 multiplies 1, it is still 2. That is how come I had 2 over a here. So this is how it is. And you also know that 1 over a is the same as this reciprocal, then you are going to have 2 times a raised to the power negative 1. Now, from this theorem, you know that with multiplication, you can combine a number and a variable. So 2 times a raised to the power negative 1 is the same. This is the equivalent sign, something like 3 dashes. It is equivalent to 2a raised to the power negative 1. Do you get it?
Yes, sir.
Good. So I just want to take you through these basics, elective math stuff, and then, so we need to expand this one. So 3, 6, 18.
Yes.
3, 4, 12 plus 6. So I have 18x plus 12 plus 6 is 18. So 18. Good. So the final answer is going to be f of g of x is equal to 18x plus 18. Very, very easy. Now try this and let me see. Try j of f of x. J of f of x. It can also be written like this. J of f of x. So how are you going to approach it?
So I pick the expression of f of x and fix it into the variable of g of x.
Exactly. So fix it and then give me the final answer.
Okay. Okay, so g of f of x is equal to 18x plus 40.
18x plus 40. Good.
Yes,
So
sir.
I have 6 into bracket 3x plus 6. And then plus 4, right?
Yes, sir.
3, 18, 18x plus 6, 6, 36 plus 4. So 18 plus 40. Very, very easy. That's good. Now with range, domain, codomain, functions, very, very easy. Let me mirror my notes for you to see. You can check my other camera. It will appear there. One minute. Okay. Okay, so can you see my mirrored notes?
Yes, sir.
So let me pick from top. So understanding domain and range. So we'll pick a question and then we'll easy to understand. So what is the domain of the function? Now f of x is equal to 1 over x plus 2. Now the possible answers, I'll explain the first one. Now when we say all integers, now we know that integers are positive and negative whole numbers. But here, when you look at the denominator, now the range simply means that now the denominator you're going to have should not render the function in the denominator to 0. Because anytime you have a fraction and then you have 0 as the denominator, it makes the fraction undefined. Even if you pick a calculator and then you type 1 divided by 0, it's math error. I mean, it's complex mathematics, not the SHS level. It's math error. So you do your best to avoid the denominator from being 0. So you equate the denominator to 0 and then you find for x. Once you are able to find for x, then it means that that value you had is the range. Now the range sometimes is the same as the domain, but the codomain differs in mapping, comma. So range is something like a domain. Now let me give you this explanation. The domain of a function consists of all of the possible values of x. In this case, we want to make sure that we are not dividing by 0, just as I said. Anytime you are given a function, what you are trying to avoid is that you don't divide by 0. It makes your function undefined. So you just have to make sure you don't divide by 0. Now, 0 in the denominator. Numerator is up, denominator is down. Since that would make our function undefined. So in the last expression I gave, when you have x is equal to -2, now this would make the denominator 0 here, this place. So there's no way x should be equal to -2. So the domain can be all real numbers except -2. Except -2. Good. Now in this one, I would skip this and then I'll use this one. Now, another thing you have to take note, aside avoiding your denominators to be 0, the next thing you have to avoid is to avoid negative sign under the square root. You shouldn't have a negative sign under the square root. So here, the possible answers for the domain are all real numbers, except for x to be greater than or equal to 2. Because when x is equal to 2, now it means you have square root of negative 2, which is complex. Yes, it is very, very complex. So there's no way your x should be 2. And then the all real is the second one, all real numbers such that x is greater than or equal to 4. Now, once x is greater than 4 or equal to 4, then it means that you are eventually going to have a positive value. And then all real numbers except 4. Now, this comes in because of the controversy about square root of 0. Because now square root of 0 is 0. I mean, nothing is nothing. So square root of 0 is 0. It is a tangible number. So that is how it goes. We won't enter into graph for now. I want us to take a lot of examples on domain and reach. Now, you can also be asked to find the number that makes an expression or a function undefined. Now, it means that you are just equating the denominator to 0. Sometimes the denominator comes in quadratic functions. So before you are able to do functions, you have to revise quadratic functions. So I want you to try this for me, and let's see. I want to give you a quadratic function for you to try for, so that I would know your strength in quadratic functions. From quadratic functions, we will head on to polynomials. Okay, so factorize this function and the possible solutions. Okay, so factorize x squared minus x minus 6 is equal to 0. X squared minus x minus 6 is equal to 0. Find the factors of this quadratic function.
The factor.
Yeah, find the values of x.
Values of x.
Or should we the first example and then
Yes,
I
please.
and one, right?
Yes, please.
Okay. So I just want to know your strength. That is why I give you these exercises to try. But if you don't know, it is no problem at all. That is the reason why we are having this meeting. So it's not anything difficult. So let's start with quadratic factorization. Now in quadratic, one thing you have to look out for is the coefficient of the x. Now this is the question. X squared minus x minus 6 is equal to 0. Is equal to 0. Now I group them. That is A, that is B, that is C. Now the first thing I need to look out for is the product of AC. This A and C. So my product of AC is -6. Now the reason why you need product of AC is that we are fortunate. In this question, the coefficient of x squared is 1. So, I mean, 1 times -6 is the same as -6. So let's assume if the coefficient of x squared was not 1, then it means that the value here will be multiplied to 6 to give you the product of AC. Yes. Now your next step is that you are looking for two numbers. When you multiply them, you have -6. When you add them, you have -1. That is the rule. Two numbers. When you multiply them, you have -6. When you add them, you have -1. So what do you think those two numbers will be?
1 and -6.
+1,
Positive
-6.
1 and -6.
Okay, so let's see. So +1 times -6 is -6. Good, so we have this. Now let's see. +1 plus -6. Now this one is giving me -5. I don't have -5 here. So we need to go into it again. So what do you think we should do to give us -1 here? Do you think we should try a different set of multiples?
Yes, sir.
Okay, so which multiples do you think we should try?
-3 times +2.
Good. So this is -3 times +2. So -3 times +2, I have -6. Now, -3 plus +2. This is giving me -1. And that is what we need here. So now that I have these values, I am going to omit the x and then fix these values there. So my next step is going to be x squared. Then I pick one of these. So x squared minus, we don't write 1x. So we just write x.
Yes.
So 1x and then -6 minus 6x minus 6 is equal to 0. Is equal to 0. Are you okay?
Yes.
Good. So I mean the one thing here, your ability to look out for those two numbers. Once you're able to do that, you are good to go. So now at this part, you realize that I have 4 different expressions. So I am going to simplify. Now I have x squared and then negative and then x. Which variable do you think is common here?
X, negative X, X.
Are you sure it's negative x?
We said they're not common variables. One is x squared, the other one is negative x.
Okay, so now let's add something. If I have x squared plus x, now see, if I bring x out and I open a bracket, you can see from here. Now, what variable do you think this x should multiply to give you x squared? What variable?
X.
X. And then I bring my sign. Now, if I need x here, should I multiply this place by a variable or a number?
A number.
Good. And what number do you think?
1.
1. So it is something like I am reversing the expression. Do you get it? I am reversing the expression. So here, my common value is going to be x. Because x can go into itself 1 and then go into x squared 2. Do you get it?
Yes.
So I x out, open my bracket, x is going to be here. So now I have x times x to give me what? X squared minus x times 1 will give me negative here because I already have my negative sign. So 1. We are done with the left-hand side. Now, negative 6x and negative 6. Which number or variable do you think is common here?
6.
6. So do you think it is going to be negative 6 or positive 6?
Negative 6.
Negative 6. Now, if I bring negative out, if I bring negative 6 out, then it means that before I can get a negative number here, now it means that I should multiply the negative number and a positive before I can get a negative number. Do you get it?
Yes.
Good. But then you realize that in quadratic factorization, if you have in it should be the same. So there's no way this can be negative or minus, and that other bracket will be positive. Do you get it?
Yes, sir.
So what do you think we should do? So let me come back to this. So this is the results we had for multiplying and adding them, right?
Yes.
Good. So here I replace it with these values. So -3 and 2. Do you get it? Let me pick it again from here. X squared minus x minus 6 is equal to 0. Now -3 and 2, that is it. -3 and 2. So I have x squared minus -3x plus 2x minus 6 is equal to 0. Is equal to 0. Are you clear now?
Yes, sir.
Good. I think I should have used this one. I was using this one. So now I factorize x out. So I have x minus 3 plus now 2x minus 6. What number is common here?
+2.
+2. So I bring +2 out. I have x minus 3. So you realize that now you have x minus 3 and then x minus 3 in the bracket.
Yes, sir.
Good. So even if you choose different sets of numbers from this place, eventually you're not going to get the same numbers in the bracket. So you need to go back and check again and make sure that the numbers in the brackets remain the same.
Yes, sir.
So now the outside values and then one of these. So I have x plus 2, x minus 3 is equal to 0. Now at this point, I am sure it is pretty easy for you to find x because you have x plus 2 is equal to 0 and x minus 3 is equal to 0. Now find the values of x and let me see. What do you think x is going to be?
X will be equal to -2 and x will be equal to +3.
Good. So you have -2, +3. -2 and +3. Good. Now let's try another example and then let's see. Okay. Good. Now find the values of x in the quadratic expression below. So 2x squared plus 5x minus 3 is equal to 0. 2x squared plus 5x minus 3 is equal to 0. Try it and let me see.
Okay.
So you need your product of. So what is your product of AC?
-6.
Good. So I have A, I have B, I have C. Complete it and tell me the values of x. So once you have your product of AC, now you're looking out for two numbers when you multiply. you have negative 6, but when you add, you have positive.
Please,
Okay.
please, I got x to be 1 over 2 and x to be negative 3.
So negative 3 and
1 over 2.
negative 3 and 1. Negative 3 and 1 over, right?
Yeah, 1 over 2.
Okay. So let's see. Now, product of A is equal to negative 6. So two numbers, when you multiply negative 6, when you add 5, what are those two numbers?
6 and negative 1.
Good. 6 and negative 1. So I have 6 and negative 1. So I have 2x squared plus 6x minus x minus 3 is equal to 0. So I just replace this 5x by 6 and negative 1. Good. Now, what is the common value I can get from here? 2x, right?
Yes.
Good. Now, 2x times x will give you 2x squared plus 2x times 3 will give you 6x. I close my bracket. Now, I have negative. Now, x minus 3. What number do you think is common there?
1.
1. So I bring my 1 out into bracket x plus 3. Because negative 1 times positive 3 will give you negative 3 equal to 0. So I have 2x minus 1, bracket x plus 3 is equal to 0. So 2x minus 1 is equal to 0. 2x is equal to 1. X is equal to 1 over 2. Good. X plus 3 is equal to 0. X is equal to negative 3. So half and negative 3. Good. Very impressive. Okay. Now I am giving you the last example on quadratic factorization, and then we will move on to polynomials, how to solve cubic functions. Cubic functions. Okay. So the last example. This is cheap. Give you okay. Factorize x squared. Let me write it here for you. X squared plus 2x equal to 15. Factorize this. Or solve for x by factorize. Solve for x by factor. X squared plus 2x equal to 15. Let's find the values of x.
So please, I'm done.
Okay. So now what do we have for?
X is equal to 3 and x is equal to 5.
Okay. That's good. X squared, x minus 15 is equal to 0. Now I have a number that you multiply to get 15, and then you add negative 15, and then you add to get 2. So you realize I have 5. And
Positive 5 and negative 3.
good, that's it. That's it. So I have x squared plus 5x minus 3x minus 15 is equal to 0. Now I bring out x, so I have plus 5. I bring out negative 3, so I have x plus 5, 0. X minus 3, x plus 5 is equal to 0. X minus 3 is equal to 0, x is equal to 3. X plus 5 is equal to 0, x is equal to negative 5. So sometimes they can ask you to find the truth set. It happens in core math. and maybe elective math too. Now, when they tell you to find the truth set, after you are done solving for the values of x, you have to state it. So the truth set is such that, like this. The truth set is such that x, so the truth set is x such that x is equal to 3 and -5. Then curly brackets, like this. This one can fetch you like 1 mark. This one. Good. Now, polynomials. Polynomials. Good. Now, our first example, factorize the expression x cubed minus 17x squared plus 54x minus 8. Minus 8. Sorry. Minus 8. Now, when you are given a question like this, the first thing you have to look out for is a constant. Now, the degree is to the degree 3. That is the highest degree you have. So x cubed, and then the next one is x squared, and then you have x, and then 8. The 8 is the constant. When we say a constant in elective math, all constants are numbers. They just say constant to confuse you. I mean, it's a mathematics term, but all constants are numbers. Very, very easy. So now, when you're given a cubic function like this, the first thing you have to do is find a factor that will make this whole expression 0 and also go into the 8. Now, if I pick 8, the constant 8, now from 1, what are the numbers you think can go into 8?
The numbers that can go into 8.
Yes, both positive and negative.
1.
So positive 1.
Positive 2.
So if you're picking positive 1, then it means that it goes along with negative.
Yes, please.
Yes. So don't forget, you always pick your positive and your negative. Yes. So positive 1, negative 1.
Positive and negative 2.
Okay. So I have positive 2, negative 2. Okay.
And positive and negative 8.
So from 2, do you think you have to jump to 8? Don't you think there's any other number from 1 to 8 aside 1 and 2 that can go into 8?
4. Positive and negative 4.
Exactly. So plus 4 and negative 4. Now, once you find out for these numbers, the next step is to pick each and every one of them, fit it inside a polynomial, and then make sure that you have 0. You have 0. If you fit it inside a polynomial and you don't have 0, then it means that that particular number is not a factor. It's not a factor. So let's fit in 1 and see. Let's fit in 1. So here I have into bracket 1 cube, that is positive, minus 17 into bracket 1 squared, plus 54 into bracket 1, minus 8. So what do I have for 1 cube?
1.
1. Good. 1 cube is 1. Now, 1 squared is 1. So negative 17 times 1 is still negative 17. Good.
Yes.
54 times 1.
54.
54 minus 8. So now what do I have? This is negative 16 plus 46. Because 54 minus 8 is 46, right?
Yes.
Good. So what is 46 minus 16?
46 minus 16. 46 minus 16.
Yes, because I have negative 6 plus 46. And it's the same as 46 minus 16.
It's 30.
30. Do I have 0? No.
No.
Good. So it means that positive 1 is not working for us. Now let's try negative 1. Let's try negative 1 if we have 0. So for negatives, anytime the power or the index or the exponent is an even number, it means you're going to get a positive. So for negative 1, if the power is an even number, you have a positive. If the power is an odd number, you have a negative. So negative 1 cube is negative 1. You get it?
Yes, sir.
So find out and let's see if we have 0.
No, sir.
We didn't get 0, right?
Yes.
Okay, so let's try positive 2. Let's try positive 2.
Okay.
Let's try positive 2.
Okay, so I'm doing it. No, sir. Yep, you didn't get 0.
Let's try negative 2 and see. Let's try negative 2 and see.
Okay. No, sir.
Okay. I positive 4. So this is a series of checks that you have to go through in order to find the suitable factor. And this is polynomial. You check out for the constant, and then you find numbers from 1 that will go into the constant. And then you pick each and every one of them, and then you fix it inside. And then you try, and then you get 0. So when you get 0, then we continue. So try 4, and then when you are done and you don't get 0, try negative 4. By all means, one of these should be 0.
So you give us 0.
It gave us 0.
Yes.
Good. So positive 4 as
Yes, sir.
good. So now we can boldly that x is equal to 0. X is equal to 4.
Yes, sir.
44. So x is equal to 4 because it is 4 that gave us 0, right?
Yes.
Good. Then, after we've written x is equal to 4, then we pick the 4 and cross the equal to sign to the left-hand side. Now, if you pick the 4 and cross the equal to sign to the left-hand side, you have x minus 4 is equal to 0. Do you see that?
Yes.
Good. Now, it means that this x minus 4 multiply a particular quadratic function and then give you this cubic function. That is what it implies. So you always look out for your constant, and then based on the constant you have, from 1 to that constant, all possible values that can go into the constant, fit it inside the x. If you get 0, now it means that x is equal to that particular number. Now cross that particular number to the left of the equal to sign. You realize that you have an equation, x minus 4 is equal to 0. So it means that x minus 4 is a factor of the polynomial. Do you get it?
Yes, sir.
Good. Now don't forget this. You realize that we have, don't mind my dinosaur.
Okay, sir.
Now we have the long division sign. Dividend is inside. Divisor is outside. And then quotient is here. Do you remember this?
Yes, sir.
Good. Now it means that this divisor or this factor that you have, when you divide it by the cubic function, then you're going to have a quadratic as the quotient. So now we carry the cubic function and this factor into the long division. So this is where the long division actually comes in. Polynomial. So once this is a factor, now this is what we would have written. Now we would have written x cubed minus 17x squared plus 54x minus 8 divided by x minus 4. Do you see this?
Yes, sir.
This is what we would have written. But you know that when we write 24 divided by 6, it is the same as 24 inside, 6 outside. Very, very simple. So if this is the same as this, then this can also be written in the long division form. In the long division form. That is how come we employ long division when you are solving polynomials. Because when you have factors like this, it is easier for you to divide using long division. Very, very easy. So now let's see how we will eventually use the long division to find our value. or the factors of the polynomial. So now I am going to write the expression in the long division form. So I have my long division sign, and then I have x cubed minus 17 x squared plus 54 minus 8. Now this factor I had is going to be my divisor. So x minus 4. This is it. So all that we need is that after we finish dividing, we are going to get a quotient here. When you multiply this divisor by the quotient, you need to have the cubic function. Now the quotient is going to start with x squared. And then you already know how to solve quadratic factorization. So actually, before you can be able to solve polynomials, you should be able to solve quadratic factorization first. Because no matter what you do, the quadratic factorization is going to be inside the polynomial. It's going to be inside the polynomial. So now, let's start dividing. Now, I pick the variable here. I pick the variable here. Good. Now, that is x. That is x cubed. Do you get it?
Yes, sir.
Good. Now, you realize that x will go into x cubed, x squared. Do you get that?
Yes.
Good. Because if I have x cubed divided by x, this is x squared. Now, by simple indices, JHS, I have x cubed divided by x. Now, any number standing alone is raised to the power 1, but we don't write it. And now once you have division in the middle, it means that pick one of the bases and subtract exponent. So I have x raised to the power 3 minus 1. Now you know that 3 minus 1 is 2. So I have x raised to the power 2. Now x raised to the power 2 is the same as x squared. Do you get it?
Yes, sir.
Good. So here, 3 will go into x cubed, x squared. Good. Now my next step is to pick this x squared and multiply through the divisor. So first step, x, the number of times it goes into x cubed is x squared. Now your next step, pick the x squared, multiply through. So what is x squared times x?
X cubed.
X cubed. Now what is x squared times negative 4?
Negative 4x squared.
Good. Negative 4x squared. Now you are subtracting the whole expression. So bracket, minus. And then you underline it. Good. Now, do you realize that this negative will affect this x cubed?
Yes.
So what is x cubed minus x cubed?
0.
0. 0. Now I have negative and negative. So what do you think it will be?
Positive 4x squared.
Positive 4x squared. So negative 17 plus 4x squared. What do you think you will have?
Negative 13x squared.
So negative 13x squared. Now I can bring all the values I have left. So the plus 5x comes down, and then minus 8 follows. So this is what I have. Now my next step, I pick the x again, and then I check the number of times the x is going into this negative 13x squared. Do you get it?
Yes.
So how many times is x going into negative 13x squared?
Go into negative 13x squared, x times.
X times there's a number.
Negative 30.
So let's see. Negative 13x squared divided by x. Now, as I explained earlier, don't let this confuse you. Very, very easy. Now, this is the same as negative 13 times x squared over x. Do you see that?
Yes.
Yes, because anytime you are multiplying a number and a fraction, it always multiplies the numerator. Very, very easy. Now, I can do this by using indices. So I have negative 13 times x squared divided by x. Do you see that?
Yes, sir.
Good. Now I have negative 13 times, because this is division, I am going to pick one of these and then I subtract the exponent. Any number standing alone is raised to the power 1, but we don't write it. So I have x raised to the power 2 minus 1. So negative 13 times, what is 2 minus 1?
1.
1. So I have x raised to the power 1. Now any number raised to the power 1 is the same number. So I have negative 13 times x. Now what is negative 13 times x?
Negative 13x.
Negative 13x. Negative 13x. So here, you can boldly say that x will go into negative 13x squared, negative 13x. Do you see that?
Yes.
Should I go over again or it's
okay?
Good. Now, once I have negative 13x here, I pick this negative 13x and I multiply through x and negative 4, like how I did to this. Do you get it?
Yes.
Good. So what is negative 13 times x?
Negative 13x squared.
Good. So negative 13x squared. Now what is negative 13x times negative 4? So it is something like negative 13 times negative 4. Then you just add your x.
52.
Good. So it's positive, right?
Yes.
So plus 52x. Good. Now don't forget that we will subtract. So your bracket and your bracket, and then you bring your negative sign, like how you did to the first one. Then you underline it. Now that is negative. That is also negative. So again will give you a positive.
Positive.
Good. So you realize that all this one will go to 0. Will go to 0. Now, negative times positive is negative. So what do you think the value is going to be? Negative 52 plus 5.
Negative 47x.
Good. So negative 47, and then I just bring my negative 8. Very, very simple. I just bring my negative 8. So my next step is to find out the number of times x is going into negative 47x.
Negative 47 times.
Good. So I have here negative 47. Then I multiply through again. So I have negative 47 times x. So I have negative 47x. Negative 47x. And then I have negative 47 times negative 4. What do I have?
188.
188. Good. So plus 8. Good. Now remember, this is negative. I underline. So this one will go to 0. And then I have negative 188 minus 8. So what do I have?
Negative 196.
So negative 196. Now, do you realize that there's no way this variable, let me show you, good, this variable can go into this number?
Yes.
Good. So now we are convinced that when you multiply this factor by the quotient, you're going to get this cubic function. Do you get it?
Yes.
Good. Now, most of the times, you work out and then you get 0 here. That is what happens. Yes, but with this particular question, there's no way you can get 0 here. You're going to get negative 96 here. So this is what it's going to be. X minus 4 in a bracket. And then you have x squared minus 13, x squared minus 13x minus 47. So when you multiply this and that, you should be able to get the cubic function. Do you get it?
Yes, sir.
So now that you have this function and you have the quadratic function, from our basic quadratic factorization, we can further split this into 2 separate devices again, so that we will have 3 different factors. Now, if quadratic is giving you 2, now cubic is going to give you 3 different factors. Do you get it?
Yes.
Good. So that is how to factor a polynomial. That is how to factor the polynomial. So for quadratic factorization, you found out the product of AC and the number of, you find out 2 numbers. When you multiply, you have the product of AC. When you add, you have the middle value. That is for quadratic. When it comes to polynomial or cubic, now you look out for the constant or the number among the expression. when you look out for that number, from 1, list all numbers that can go into that number, both positive and negative. Once you list them down, pick them and then fix them inside the cubic function. The one that gives you 0 is a factor of that cubic function. So it means x is equal to that number. And then you cross the number from the right-hand side to the left-hand side. So you're going to get an equation, something like x minus 4 is equal to 2. Good. Now you carry this new factor, which is a divisor, and the dividend, which is a cubic function, into a long division. See, it's a process. Once you are able to get the process, it is going to be very, 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 very easy. Let me find one example for us to do. I want to look out for another polynomial question. Okay. So let's see. Okay. Okay. Now factorize the following polynomial. I have 2x cubed plus 7x squared plus 7x plus 2. 2x cubed plus 7x squared plus 7x plus 2. Factorize it.
Yeah.
Yes.
Is I got the quotients to be 2x squared plus 5x plus 2.
2x squared plus 5x
X
plus 2.
plus 2.
Great. 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 And then you have the divisor to be
X plus 1.
good. Now factorize the um, the quotient, and let me see. What is your product of AC? 4, right?
Yes, sir.
Good. So now two numbers. When you multiply, you have 4. When you add, you have 5. So factorize the quotient and then get two sets of divisors so that you will know that you have 3 different sets of divisors for the cubic function. Do you get it?
Please repeat what you just said.
Okay. So now pick the quotient and factorize it again.
Okay.
So what is your product of AC? 4. Good. So now you're looking for two numbers. When you multiply, you have 4. When you add, you have 5. And continue and get two separate divisors. So in the end, you should have 3 different divisors that is equal to the cubic function. You get it?
Yes.
So find it and let's see.
Okay, so say
Okay.
x is equal to negative 1 over 2 and x is equal to negative 2.
Good. So now you have 3 values for x. But with this one, because they didn't actually equate it to 0, they didn't
Okay.
equate it to 0. So your answer should still remain as a divisor.
So x minus half and x minus 2.
So x minus 2. So now the x minus half, don't you think it is 2x minus 1?
Yes, 2x minus 1, yes.
Good. Good. So now, just as you have in quadratic functions, 2 sets of divisors that makes up the quadratic function. Now the cubic function has 3 sets, like what you've gotten. That is how you solve the polynomial or the cubic function.
Yes, sir.
You get. So at this point in time, I think you are okay with polynomial. Or do you have any other questions on the polynomial?
No, sir.
Okay. Okay. So what was the last topic you did?
Let me check.
Check the last topic you did, and then the ones that are not difficult, we are not going to waste our time on it, so that we can move. But you're
So it
doing elective math.
was division of polynomials.
Okay.
Yeah.
Multiplication of polynomials.
Division.
Division of polynomials.
Yes, sir.
And that is what we've done.
Yes.
So it's not anything difficult. I'm glad that we've been able to clear this one out of the way.
Okay.
Have you done sets?
Sets. Yes.
Good. Have you done 3 set problems?
3 sets problems. Yes.
Good. Have you done binary operations?
Binary operations. No.
What about number bases?
Number bases. Yes.
Good. Have you done modulo arithmetic?
No, sir.
Okay. So the next time we meet, I can pick it from sets.
Okay.
You get it? There's a past question, 2017, core math. I don't know your curriculum. Are you writing WASI?
Yes, sir.
Okay. Because some people are writing A level and O level. So I think you can check out the 2017 WASI. There's a set question in it. And we will discuss it the next time we meet. When do you think we should meet again?
Maybe Wednesday.
Okay. Same time?
Yes. 7,
okay.
right? 7 p.m.
Yes, 7 in the evening.
Okay. Yes, sir.
Yeah. So we'll make it on Wednesday then.
Yes, sir.
Okay. So I'll meet you on Wednesday. Have a nice week.
You too. Thank you, sir.
You're welcome. Bye-bye.
Bye.
Bye. Okay, so thank you very much for watching. You kindly subscribe to my channel and watch out for more of these. Thank you very much.